Hi class, this is course 3, lesson 10, rational numbers. We have another set of numbers that we can talk about. They're rational numbers, and they are numbers that can be written as a ratio of two integers. And we're going to represent those as fractions. Most integers can be represented as, all integers can be represented as rational numbers by putting a 1 under them, like the number 4. 4 can be a fraction by calling it 4 ones. Okay? Well, rational numbers are that ratio of the two to any two integers. So negative 1/8, positive 2/13. Any number that can be written as a fraction is a rational number. And you're going to want to put this diagram on your paper. You can use circles, you can use squares, whatever it is, but this kind of helps you see the relationship between them. Counting numbers are where it all starts. Then we add the whole numbers and they include the counting numbers. Integers include all of the whole numbers and all of the counting numbers. And rational numbers include all of them. Okay? And I don't remember counting numbers are like 1, 2, 3, etc. Whole numbers add the number 0. Integers add the negatives. And then if you think of a number line, rational numbers are going to include all of those other numbers that are in between. Okay, it's all those fractional components. Okay. Here's some information that you need to make sure that you have in your notebook. We're going to talk about sets of numbers that are closed. Okay, so the whole numbers, that's a set of numbers, and they're closed under addition and multiplication. And what it means to have a set that's closed is that when you use that number, the whole numbers, in those two operations, in addition and multiplication, the result is always going to be a whole number. Okay, so the sum or product of two whole numbers results in a whole number. So if I take 2 times 8, I get 16, which is a whole number. If I take 1 plus 0, that's 1, that's a whole number. I will always get whole numbers. That's why this set of numbers is closed under addition and multiplication. Okay, integers are closed under addition, multiplication, and subtraction. So I can add, subtract, and multiply. The sum, the product, or the difference of two integers results in an integer. Okay, so no matter what I do there, add, subtract, or multiply, I get an integer. So negative 1 plus negative 8 is going to be negative 9. That's an integer. Negative 2 times 6 is going to be negative 12. That's an integer. The integers include the whole numbers, so you already know the positive side of things. Okay? Now the rational numbers are closed under addition, subtraction, multiplication, and division. And why is that? Well, because division is going to represent things like 2/3. 2 divided by 3. Well, that is a rational number. Okay, so hopefully that makes some sense to you, and if it doesn't, please ask me. But that should all be in your notes. Okay, equivalent fractions, we talked about that in class a little bit. Name the same amount but have different numbers. Okay, so if I have the fraction 1/2, I can multiply that fraction by like 4/4. And this 4/4 is just the number 1 written differently. And I know that if I take a number times the number 1, I will get that same value in return. That's the identity property. Okay, even though the numbers look different on the outcome, it still is the same amount. 1 times 4 is 4, 2 times 4 is 8. Okay, 4/8 and 1/2 still name the same amount. 1/2 times 1 is going to give me a fraction that looks different, but is still a half. Okay, that's identity property. And I could work I could work backwards. 3/9, I could divide that by 3/3, which is still 1, and get 1/3. 3/9 and 1/3 are equivalent fractions. Okay, this section of the book seems to have quite a few different vocabulary terms and things just thrown in there. Greatest common factor is another one of those items. It's the largest whole number that is a factor of 2 or more numbers. And we can use that to simplify fractions, which is what I did up here. Greatest common factor between 3 and 9 is 3, so I divided by 3 and got my simplified fraction of 1/3. But we can also use prime factorization to find the greatest common factor. Okay, so we're going to practice that right here. So you're going to get problems that say use prime factorization to simplify, and my fraction is 20 out of 36. Now, you might be able to do this a different way, but when it says use prime factorization, we're learning a new skill, so you need to use prime factorization. So, use that factor tree, or division by primes, 4 and 5, and I know 5 is prime, and 4 is 2 and 2. Okay, so those are my prime factors for 20. And 36, let's see, 4 and 9. 4 is not prime, so it's 2 and 2. And 9 is 3 and 3. Okay, so what do I do with this? Well, 20 can be represented as 2 times 2 times 5, so that's what I'm going to do up here. I'm going to represent these two numbers as a product of their factors, their prime factors. Okay, so 20 is the same thing as 2 times 2 times 5, and 36 is the same thing as 2 times 2 times 3 times 3. Okay, now I can divide out, simplify my fraction if I have the same factor on either side. So if I divide a 2 out, I get a 1, and a 2, I get a 1. And 2 divided by 2 again is 1, and 2 divided by 2 is 1. Now I have a 5, a 3, and a 3, and that's not going to pair up at all. So multiplying through again, I'm going to get 5/9. So this fraction simplifies to 5/9, and that's how you do it using greatest common factor, prime factorization. So then the follow-up question would be, what is the GCF, greatest common factor, of 20 and 36? Okay, well, that is the number that you crossed out on one side of the fraction bar. Okay, so it's not 2 times 2 times 2 times 2. But if you look at the number that you divided out or crossed off on one side of the fraction bar, it's 2 times 2, which is 4. So we divided 20 by 4 and got 5, and we divided 36 by 4 and got 9. Okay, so prime factorization is going to help you find GCF. Okay, and then just making sure that we understand the mixed number to improper fraction transition. If I have 2 and 3/5 and I want to make that mixed number into an improper fraction, you multiply here and then you add here. So it's 5 times 2, which would equal 10, plus 3, which equals 13. And then you keep the denominator. So this fraction as a mixed number as an improper fraction is 13/5. Okay, and working backwards the other way, if I have 18/4, I would just divide that. So put the 4, the divisor outside, put the dividend 18 inside. 4 goes into 18 4 times. 16 minus 2. And then this goes up here. Your remainder is the numerator. The divisor is your denominator. And then 2/4, I can divide that, right? Simplify it by dividing by 2 over 2, which is going to be 4 and 1/2. Okay, be very careful when you get a problem like this. If you just put 1/2 here, I'm likely to count it wrong because it needs to have that whole number in front of it. Okay? So that's a lot of, well, several different items there for you to keep track of in lesson 10. Please let me know if you have questions. Thanks. See you in class.